Our project topic is the 3D reconstruction of column based on depth learning. My name is Wenrui Zhao, and my teammate's name is Hanwen. Because our topic is mainly about the 3D reconstruction, so we put most our attention on getting the depth map from an image. And also we try to get the camera parameters and some information about the motion, because maybe they can provide the possibility for get further motion analysis in the future. First, I want to talk about the frame that is designed by a Google research team. Because we use a similar frame with a little difference, but in a totally different field, which is the medical field, about the column. First, we have to put two images in the depth network, and the depth network will apply it on them independently. And we can get two depth maps about the two images from the depth network. And then we will put two original images and their depth network in the motion network. The motion network will give us the equal motion information, which is stored in a six-dimensional vector. And also we will get an object motion map. With those two things, we can get a whole motion map. But there's a very important assumption for that frame. It is that most things in that picture should be still and rigid. For example, the Google research team mainly use this frame on the picture of street view. Of course, the block and the street is still and rigid. And there will be also something, for example, the cars and people are moving. And I think for our project, the column could not be totally still and rigid. But there's only some part of it are moving. So I think we can also use that frame on our project, and actually it performs well. And I have to talk about the data side. It was really difficult for us to find a suitable data site, because it's a really specific field, and so at last we finally found a 298 picture of the human column, but it's simulated by another team of Google research. We use them instead of finding some real picture as a data site. For data pre-processing, we first perform the grayscale processing on the images, which allows us to better extract the edges and the light information. Then we feed several sets of the processed images. For data pre-processing, we first perform grayscale processing on the image, which allows us to better extract edge and light information. Then we feed several sets of pre-processed images of two consecutive frames as the training data to the depth network. The depth network is a combine of ResNet 18 and UNet. This method uses single view depth and multi-view pulse networks with a loss based on warping nearby views to the target using the computed depth and pulse. The most special thing for that network is that this method is completely unsupervised, requiring only monocular video sequence for training. And after training, the while training network, the depth network, will no longer need a picture of another frame continuous with the picture to be predicted as the basis, but we can directly get the depth map from only one picture. And since its prediction function is not open source, we have to implement the prediction function for the dataset we are using. After testing and a small number of parameter adjustment, the network's model performs really well. The picture below the grayscale in the slides are mainly purple, which are mainly purple pictures, which are the predicted depth network. The depth map, in which the darker pixels represent the greater the depth. Another thing I have to talk about is the loss function. The training is driven by a number of self-supervised loss function. The total loss is the sum of three components: the motion regularization, the depth regularization, and the consistency regularization. The motion regularization and the consistency regularization are applied twice on the two pictures, the frame pair, and the order will be reversed in the second application. And the depth regularization is applied independently on each one of the pair. And as you can see in the slides, the loss function dropped and stabilized. Based on the depth map, we can observe the 3D structure of the column. Because we lack the ground truth in reality, we can only evaluate the results of our model through the directly observation. It can be seen from the picture that the depth map is basically consistent with the conventional structure of the column. The main error is that there still exists some spot-like errors on the depth map. It is because that the line on the column may affect the depth prediction. In addition, we try to get the camera parameters and motion information through the motion network, which is mentioned in the frame of the Google research team. It is a simple CNN, and we start the results in a 6-dimensional vector. But actually now they are not very high accuracy. But if we can improve the accuracy in the future, I think it can help us to get a whole motion map of the column, which can be really useful in the medical area, I think.